Welcome back. It's Elliot here at Engineers. Thanks very much for joining us. We've got the delight of Ben Gamble here at Ably. Ben's going to tell you a little bit about Ably, the business, and how they support some of their customers. They're a seriously cool API connectivity messaging platform. So he's going to talk to you all things around resiliency, scale, and his role as a Devrel. Thanks for joining us, Ben. Do you want to tell us a little bit about you, the business, and some of the stuff that you're up to?
Well, thanks for having me on, Elliot. Ably is, Ably is, as Elliot mentioned, a kind of real-time messaging platform. We do the ever classic pub sub event routing type deal. Our kind of secret sauce is basically focused on a kind of core of reliability. We do in-order reliable messaging with a very high SLA guaranteed delivery, and we do that at almost any scale you would like to see. What that really kind of boils down to is things like your chat, your interact messaging, your kind of logs, your ability to stream data from place to place. We'll provide that for almost anybody. And a bit about me, I suppose, is my background is in a mix of hardcore engineering problems like route finding, 3D gaming, and also augmented reality. And I joined Ably relatively recently to head up the Devrel team to try and basically show the world what Ably can really do for them. It's a bit of a split role between some hardcore engineering of building kind of systems on top of Ably, along with kind of like aiding in with clients on their journey to use Ably better. So it's kind of like a bit of partner engineering, a bit of sales engineering, a lot of product marketing type stuff, and a decent amount of demo building, which is always the fun bit.
Okay. So there's quite a lot of API connectivity and messaging platforms that are out there. So do you want to talk to us a little bit about not necessarily your competitors, but maybe why you're different to some of your competitors and why a business would use you guys?
Okay. So it kind of comes down to like what you're actually trying to achieve. Like in most cases, like the classic thing everyone thinks to when they think pub sub and they think real time is chat. So, this is whether it's your support channel, whether it's like a social media type application. It's how do I send someone a message within a very small number of milliseconds so they can reply quickly and so a conversation can be furthered. When you do this over REST, you end up with the problem of it doesn't scale that well and it also consumes a lot of resources. So a classic thing would be like what we do for HubSpot, which is we provide their chat service. And like, I suppose that kind of like, that's part of the first part of this is being able to provide the ability to send a message very fast from point A to point B reliably. The kind of other kind of use case is something like scores for a sports game. So you stream your scores to a number of users, and this is a kind of a big fan out problem, as it's often referred to, where you have a number of listeners to a channel or a topic in classic pub to sub vernacular. The idea there is that you need to be able to send this message to as many people as are listening, but not more, but also be able to have that number scale up and down. What happens with something like Ably is we provide all those pipes. We say any number of people can listen, and we'll make sure the route from them to the source of the message is maintained. They always get their message within a very nice guaranteed window of time, and that they will always get them in order. Where we differ from our competitors, I suppose, is fundamentally they do very similar things. So PubNubs and the Pushers of the world all have kind of the same kind of principles at heart, which is they want to be able to do publish subscribe messaging, they want to be able to send messages relatively fast, and they want to be able to fan out. But where we kind of differentiate ourselves in is this kind of like the core of our technology is that we built from the ground up to be reliable, to be idempotent or send once, and to basically maintain this kind of like rigidity of the system. So both reliability and availability. So auto scaling up, scaling down when necessary, but meaning that we will not fall down under load and we will never kind of drop our quality under load. What that allows is something like Tennis Australia to say as many people as are watching can just see their scores as they pop up, and it won't fall over. It will just keep going.
Okay. Are you able to take us a little bit deeper into that and what we're likely to see under the hood from a reliability aspect or an availability aspect? Can you just give us a little bit more detail on
Sure
that?
thing. So the kind of core of this is that to have any sort of reliable system, it must be in more than one place at once. So we have multiple points of presence in every region we're available in more than one physical data center. So like the core of reliability, as kind of like everyone will say, is the first thing is there must be at least two of them. And so we kind of maintain this. There's more than one cluster in a region and in more than one physical location. We are backed into we're backed by AWS, who provide our kind of hosting. But like the idea is to make sure that every point of presence that AWS has, we have something there so that we can have a failover in that region. So we have multiple presence points in each region, in each physical data center, because everyone who's used like any sort of product to scale knows that there is no such thing as true fallibility or infallibility when it comes to physical infrastructure. So it's all about saying, how can we spread the risk? How can we make sure we always have this capability in various regions? But then to go one step further about the availability is it's about the kind of the edge story. It's about saying, how can we put a point of presence in these edge acceleration centers so that we can guarantee the shortest route for anyone through the network. We take advantage of some of the kind of faster backhauls available, but on top of that, we also make sure that we are routing people to the best edge point for ingress into the network. So we have multiple edge points of presence and then multiple redundant data centers across that kind of backbone network, so that when someone wants to try and send a lot, firstly, the pipe is short, so there's no extra delay. Secondly, there's a lot of capacity available at a local geographic to them location. So if you're sending lots and lots of stuff, we don't want it centralized because that means the central server is going to get completely hammered. So instead, it can be distributed smoothly and then kind of scale out through the system.
There's lots of topics of conversation around auto scaling at the moment, whether that's horizontally, vertically. What are your thoughts, or can you take us a little bit deeper into what auto scaling actually means, or how to actually introduce that into a business?
So it kind of comes down to a couple of very key factors, I suppose. Uh, in the kind of more general sense, autoscaling is having a way to sense when your load is increasing, having a known threshold at which point you want to add additional resource to the system, and understanding the characteristics of how much effort it takes to add this resource. So, if you imagine just having servers that consume inputs over time, and a classic thing would be a load balancer, which just goes around each server and gives each one a request to handle. As you add more servers to the pool, you can obviously handle more requests. But the problem is that as you can't add these instantaneously, they take some time for provision. They're not immediately ready to, shall we say, go from the get-go. So autoscaling becomes this kind of balancing act between how do I have the provisioning ready so that I can add more servers to my stack without paying too much for otherwise idle servers. So at least from the Ably perspective, it comes down to having a lot of instrumentation into the system and a lot of like pre-built things ready to go, which can be added to our clusters so that we can just add resource quite incrementally.
Nice. Okay. Um, Talk to us a little bit about the values of security within the business. Obviously, I'm starting to hear more about resiliency, hardcore engineering and high load messaging. So there obviously in this day and age has to be some level of security or security aspects to that. How are you guys able to ensure that these messages get from A to B securely?
There are kind of like, as with every good tech answer, it depends. So a lot of what we provide, we have a default level of security, I suppose, which we provide, which is that everything we send tends to be binary, and we don't read anything that goes through the network unless unless there's specific things where you have added rules to our system, which would otherwise allow it. We kind of support both message pack and symmetric encryption end to end if required by the client. We also specifically use like token authentication for everything in and out of the system. The problem ends up being that like a lot of what we do to make our system secure is very much dependent on client implementation. Like, so we provide tools to allow a client to say symmetrically encrypt your data using AES 256 or equivalents. We provide tools to allow you to message pack your data down to binary or other similar type protocols. But it is like, for us at least, like we provide a client with all the tools, but then what we have built on top of this is like a global rate limiter, ways to tell per account level limits. And a lot of a very kind of like part of our kind of availability promise, I suppose, is about this kind of idea that, though we can scale out to whatever you need us to do without, unless you have specifically got your account set up to do that, we have a kind of a fair use type rule in place, which is that, if you start hitting your limits, we won't let you send more. So we'll start rejecting messages because for us, it's about availability again. We guarantee our system is available for everybody who's using it. But if you want to use more than you've asked, when you've already been asked, we've been asked to provide for you, is what happens is we'll effectively start rejecting your messages. We are very kind of upfront about this, as this is a core behavior of our libraries and the way our system works. But like that's part of, I suppose, of our security is this anti-abuse. Like we have the usual levels of like encryption, secure systems, and like internal network versus external network, but we go through the public cloud, so best practices are followed all throughout. But for
Sure.
abuse, which is the classic problem with PubSub, is we have rate limits. We have both soft and hard limits where you'll get a probabilistic decay of your ability to send a message as you exceed your boundary. So if you're sending twice as many messages, half of them will get through, but which half is kind of dependent on literally fluctuations in the net, because it'll be which one happened to tick the counter down first.
Okay, interesting. Can you take us back to actually Ably, just as a business, and actually some of the companies that you partner with and what messages you might actually deliver? Obviously, you've given us a couple of examples, and actually give the audience some indication as to what sort of scale, if you can, at peak times, that the business is likely to see, just so we can comprehend some figures here.
Sure thing. So the numbers get really large. It goes up to billions of messages sent per day,
Wow,
multiple
okay.
tens of billions, right? Like it's because what happens is, if you imagine, is like something like let's say it's a tennis match, because with Tennis Australia is they have hundreds of thousands of viewers, so every single score update sent goes one message in, a few 100,000 out the other end, right?
Okay.
And let's say it's the full Australian Open, so however many times someone scores in the Australian Open, I think from kind of like rough guesses, something like 10,000 points are probably scored over which are broadcast. So if each of those 10,000 has 100,000 watchers or receivers, it could be, because it could just be digital systems receiving as well, is you start to get the idea of that's quite a lot of messages sent.
Yeah.
And each message might be more than one, because they might be sending multiple per court, multiple per thing. So that's kind of like what the scale of a single event is, and they're just one customer, right? To go back to your kind of like thing about use case is what Ably is and isn't is kind of a key thing here. Is like we're not a video streaming service. We don't stream video data or audio data. We are a message service. So our message size is quite capped to about 4 kilobytes. And what that really means is we're there to send the data which matters, often nearly always textual or numerical data. Log files are a very big area of interest right now. But it's kind of things where you need a small amount of information, which has to be in order and is highly important and has some level of client value. So chat is critical, particularly for like onboarding people. So it comes down to like what is highly valuable to the user. So in most cases, so for HubSpot, it's chat. They use like all those little windows on any HubSpot powered website. That's an Ably channel or two talking. They do a lot more than just that, but it's kind of like that's part one. Another really cool use case is things like IoT. So we provide edge presence and, of course, do MQTT broking, which is kind of like that thing Ably does, and we don't talk about loudly enough, which is like you could have any number of MQTT sensors, and we have brokers effectively in every edge presence location, and we ingress these through and can send them out into whatever large system you like via Kafka, Kinesis, or any other service like that, because we do support these additional protocols on top of just our own messaging. So we have clients who Toyota's racing team, one of Toyota's racing teams use us to do in-car telemetry. And it's things like, we'll do anything which requires high speed and high value, more or less. And the only reason I say high value is because in general, these things are pretty cheap per message, but you wouldn't want to, wouldn't need to go to anyone to get reliable messaging unless it mattered to business. And that's kind of like our kind of raison d'etre in a lot of ways, is we want to make sure that those business messages which are critical to you making money arrive on time and in order.
Yeah. Okay. How do you guys, and it seems that you've got some really solid traction, and I think messaging goes on where people don't really expect it to go on, and you just expect those things to land in your phone in an in-car service. So it's really nice to see the product brought to light a little bit more. Sorry, go on.
No, keep going. I suddenly realized you hadn't quite finished.
Yeah, I was going to say, so what happens, when we've talked about the resiliency of the messages, what happens when that scale continues to hit an upward trajectory and there's mass adoption? Because mass adoption is one of those things that companies want right now, and it's one of those things, especially in B2B to C worlds or B2C worlds, that everyone wants their product just being used by everyone. So how do you keep that same consistency, and how do you ensure that the scale keeps on hitting that upward trajectory so it keeps everyone on the business side smiling and I'm sure happy?
So yeah, you kind of alluded to a key point there, is we are effectively a B2B2C type play. Everything we do is a tech product which is generally used by other SaaS or equivalent providers to power something they're doing. In the kind of ideal world, the fact that Ably is being used is normally invisible to any end users, as we are normally embedded deep within a client's piece of software. And in our minds, at least, our kind of highest goal is to be that truly invisible layer everyone just sort of trusts and expects.
Yeah.
To go kind of one step further about scaling, I suppose, from the scale perspective, is it comes down to, as I was saying previously, about availability and kind of almost being kind of very deliberate about being fair. The network from the ground up was designed around the kind of principle that everyone must be able to send a message if they've provisioned for it. So our provisioning is quite aggressive. We run a lot more servers than most of our clients do per message, I suppose. We don't believe that it's fair or right to actually fall over before someone else does, because we want to be that reliable thing first. So although we have of course had to scale up a lot on occasion for very specific usage, generally it's a matter of we tend to know ahead of time if an event is going to be, shall we say, crazy popular, and we can provide additional resource kind of at a kind of per minute basis level. Anyone who's on our enterprise program, we provide burst capabilities up to 25 times their expected rates. And that's just by default. Like hell, on a free customer, you get triple, I think, your burst rate if you get, for a short period of time before, we'll start asking, are you sure things are okay? But it's one of those things where, for us at least, it is kind of mission critical that we don't fall over first in a lot of ways. We are there to provide that serious infrastructure behind the scenes. Everything we do will scale. In most cases, we do like to be told ahead of time if someone's going to start a big streaming match of sports scores, or that they are starting a Twitch stream with 100 million viewers. We don't do anything with Twitch right now, but that's sort of the area we'd like to try and work it.
Twitch,
but it's those sort of things. Oh yeah, if Twitch are listening, please come along. We'd love to talk. But it's those sort of things, if we know the scale is going to be there ahead of time, we'll of course provision for it aggressively. because we can. As part of our tooling, I suppose, is internally we have all these kind of knobs and dials that mean, right, turn the autoscalers to scale faster, or pre-provision an extra, like billion messages a second of capability. It's not quite necessarily that aggressive, but in general, the network, because it is quite large and we have got a lot of customers, any individual who starts scaling that aggressively will see it ahead of time. And but if we're running out of capability, in general, that means AWS is running out of capability as well. And they like us because everything we do just uses so much of their infrastructure.
Yeah, I was going to say, is that, well, there must be elements of smart engineering here, to ensure that you're using the right amount of AWS leverage against cost. There's always going to be that argument. You don't necessarily need to talk about figures, but how do you find that balance between cost and smart cloud engineering? Or how have you seen some of your experience find that balance?
So in my previous roles, this was actually an ongoing question in many of the other places I worked, because I previously worked with teams such as like Hadian or with Improbable and other very large cloud style plays where where it was basically better ways to actually use the underlying architecture itself. And Ably is no different in a lot of ways to in fact what you're providing is a kind of a layer on top of a service, and then how much your layer consumes in cost is actually becomes, say, quite a challenge. Uh, this is where it kind of comes down to kind of we are not always the cheapest provider, and we are very transparent with how we price. Literally, we price by two things, which is number of messages and number of channels you use.
Mhm.
And there is nothing really else we charge for besides the obvious support type levels which you buy with enterprise or business. And beyond that, that's it. We people come to us because we're transparent on this. Our margins aren't necessarily as good as probably some of our competitors are, but to be honest, that's at the cost of providing of the service. We couldn't give the same availability guarantees. We couldn't idly promise many nines reliability without saying, fair enough, we'll take a bit of a hit on our end, but what, you'll come back every time because no one else can do this. And that's kind of the thing. It's there was a recent thing I read about from uh, Atlassian, which is that their whole thing is that they are cheap because they want to sell at volume, and their whole point about selling on the web and doing it all is that everything just must be available. And if their margins take a hit, so be it. But they're there to sell at volume. We're not quite in that same kind of category, but our point has always been that we're going to make sure that performance and sustainability of your service is number one, and that's something we'll never let decline. And then on top of that, we're going to try and make some money, yes, but
Yep.
it's not front and center on us. It's about delivering that service which clients really need and keep coming back for.
Yeah.
Because most of our business is, of course, is people who know they need this technology anyway, and they come to us to say, so and so couldn't provide in order messaging every time, had reliability issues, didn't have a very good support system, wasn't willing to engage with us on a highly technical level, or we did not understand their pricing, which is a very common thing actually. So it's just a matter about us. For us, it's about really being very transparent to our customers of what we charge and why. And then beyond that, as long as the service works, that's where we're going first.
Yeah. Okay. I don't want to be too buzzwordy at all. Okay. We've touched on some really good aspects that appeal to the audience. I've shared and been really transparent about sharing what the mission for engineers is, and that is about sharing, and it's about learning from other companies and other individuals within the industry and the community about what they're building. And I talk to a lot of engineers, and it's really important for them, or they would like it to be important for them, about going into an environment where they're working on things around scale, resiliency, performance, or building something mission critical. Okay. Um, what's your advice for someone, or how abstract does your thinking need to be when thinking about building something like Ably or building something for scale? That can be at a lesser scale, but
Sure.
just talk to me about what you actually need to comprehend as an engineer and think about to be able to put yourself in a situation where you're better positioned to build something like this or work on a product like this.
So this is where it comes down to almost a split mindset you've got to maintain. So kind of like Ably is an interesting case where at the very beginning, the founders sat down and went and wrote a lot of maths out to prove how it would actually work on a mathematical model, right?
Okay.
They wanted to prove a mathematical idempotency of the network. They wanted to prove have a kind of a formal proof of like availability, and they kind of built these four pillars of Ably around like availability, reliability, performance, and integrity of data. And those are kind of the four pillars Ably is built on. And they're a bit abstract because there's things like always in order, every message delivered. They're about a limit, like an actual millisecond kind of banding between two fixed points. And then obviously what availability means is about, always having something to send to, and reliability meaning when things start failing, it doesn't go wrong, like dynamic persistence and the rest of it. Some of this is very abstract, and I do mean there was probably like, I've heard Paddy talk about, solving this almost on a whiteboard first before code was written. And like that level of abstract is actually quite key when you're trying to go to a very large scale. But the split side of this is that without an understanding of customer requirement, you're kind of not building anything useful.
Okay.
Like, in the past, it's been, hey, we want to build a new OS for cloud development. And that's wildly abstract, right? No real bearing on the real world. Then it's like, what do clients need, which would necessitate this to begin with? Find the client kind of, the product market fit almost.
Yeah.
So without like trying to sound pretentious, I suppose, is like you kind of need to understand the kind of the two sides of a product market fit of we're building this because there is a need for it, or if we build this will generate a need because it is strictly better than something that already exists, and it's a problem. And then the other half of that is enough theoretical understanding of these large scale problems that you're not going to run into, shall we say, the obvious things. Classic being send once, kind of like things on a distributed system. How do you ensure a message only arrives once, only does its payload once when it has to be sent through multiple routes? How do you kind of, like do a distributed hash table, which is a fun thing we have articles about? And then kind of going deeper again, it's like, we recently posted up an article about one of the big problems we had with Cassandra, which apparently is a well-known thing which has recurred a few times about atomic counters and things. But like, we're really happy to keep talking about things that went wrong with technology we use, because we find that, the community comes back to us with interesting things saying, that's brilliant. Love to hear these kind of postmortems. And it spurs a conversation with willing engineers to engage with us. Like we want to be seen to be, talking about hard engineering problems, because A, it helps us find better engineers, and B, it helps our engineers find more better answers.
Yeah, that's good. I often think about or my thinking when I arrive at a problem where I'm thinking, I don't know how to solve that. And it's the common case of you don't know what you don't know. So you're almost stuck in your box of trying to figure out things that you've learned. Where can you step outside of that box and go to places that will give you these answers? Do you think? I know that's probably putting you on the spot, but where can people go and get this content aside from Ably? Because you guys are doing some really interesting stuff. But if people wanted to start looking at distributed systems, where can you go and find this stuff?
So the problem with some of this the information in this kind of space is it's everywhere, and it's not in one. There's very few places which have like a good kind of primer on distributed systems.
Okay.
There are very few good primers on any truly hard computer science problem. Like you can go and read Dennis Ritchie's books on the art of computer programming if you really wanted to, but unless you're that versed in assembly and like reading about tape drives once in a while from the 70s, they're not actually that valuable to the modern programmer. So you end up with this kind of like dichotomy between classic old school hard problem math type books and slightly thin articles on the web once in a while. So this is where it kind of, for me at least, like in the past, it was just learning about how cache locality worked was a big thing. I remember having to like get my head around. This is back in the days of high performance simulations, high performance games. Was like, how do I learn this outside of like finding someone to tell me about it? And experimentation will only get you so far because you don't know what you don't know,
Yeah.
right? You kind of are like, an experimentation only gets you so far if there are concepts which are, should we say, alien to you, because you just don't know what you don't know. Like this is part of why we publish a lot of content, right, on our website, is because we want people to be aware of that. We're genuinely solving a hard problem here. Like anyone can roll socket.io and go, hey, I've got sockets, it's all good, I could do real time myself. But that only holds up so far until you reach a point where it's like, oh, I've now got 100 million messages to send, or what happens when this stuff disconnects, and what happens when my message is in flight. And there's things that, like, the situation is nearly always there's still more work to be done.
Yeah.
But like coming back to learning, it's like I remember learning some of the more interesting stats stuff from when OkCupid used to publish their stats blogs way back in the day. And those were fascinating because they talked about like proper distribution techniques, like actually fair sampling techniques and what that actually means. And like most tech companies have a tech blog these days, which are great places to learn, if occasionally a bit siloed on what technology they'll tell you about.
Yeah.
In general, I find conferences like one of the few good places to still learn, particularly the language level ones. Learned a lot from CCPCon, particularly their videos online. Like my team do a lot of presentations at places like Halfstack to try and just examine hard problems.
Okay.
The community is still probably the best place to learn.
Yeah.
But it is hard, and like it's a genuine skill to know how to learn and how to explore these kind of hard spaces.
Yeah. I almost you can apply common sense isn't the right way to put it, but you can just apply life experience that maybe assume things go wrong and question everything. I think is a really good
That
place to
is
start.
absolutely right. Yeah. Like if it can go wrong, it might go wrong is a pretty, it's probably the first bit I'd say in distributed systems programming is it will probably fall over. What happens when it falls over?
Yeah.
And just like it's almost kind of programmatic cynicism in some respects,
Yeah.
right? You have to start when you start getting to big systems, you basically have to assume that you can't take anything for granted after a certain scale. Like when you have 10 customers, you can pretty much rely on the scale of one box on AWS, one EC2 instance, all is good. Then when you get to 500 customers, you start thinking, what happens when that box falls over? So you end up with 2 boxes. Then you go, well, what happens when one box falls over, but the data is lost? So you think the database out the boxes. And then as you go up and up and up and up, you start thinking, like, what happens when the pipes get congested? Then you think load balancers, and then as the system gets bigger and bigger and bigger, you get this kind of web of bits. But then what happens is, if you haven't designed these in to begin with, is you end up with this kind of thinking of, oh dear, I've got to pull apart this massive monolith.
Yeah.
And it's not good. But modern architecture, on the other hand, is also, this is the problem of if you start trying to build that Netflix mesh of every microservice under the sun, you suddenly have a system of how do we even build this? How much work do I have to do to get to value?
Yeah.
And that's that's where service providers like us come in, is you could go out and build an Ably. It is difficult, very difficult, but it is doable. A lot of the kind of base knowledge exists.
Yeah.
You wouldn't necessarily match us on quality, but it would take you 2 years and it would, untold millions worth of man hours. So unless you in most cases, it's just not worth your time to do it, which is part of why services like Ably exist, I suppose.
It's just what I find fascinating, absolutely fascinating, and one of the reasons why I wanted to build, engineers for sharing content as well. I just find it fascinating that you have to add pieces of metal to a moving car and redesign it while keeping it running. It's just for me to try and understand it is tough. So that's why I find it fascinating.
It's amazing though, because when you have to start when you start trying to say engineer out a product. So previously I used to run a startup logistics startup And we used to have like these really large servers that did all hard number crunching, right? And they used to run for 6 months at a stretch because fundamentally the math never really changed. But like everything around that was just chopped and changed almost every day, because we'd kind of we had originally had we had a lovely bit of time, I suppose. Disadvantage at the time where we just had to bootstrap with no clients and say, right, how can we actually engineer this to fit, and how can we make the bits changeable? And what happened there was, in a very real way, is like you kind of learn that like you must do these kind of classic design patterns, like design to an interface. And this is where you get back to kind of like so there are some truisms. So the famous Gang of Four book, Design Patterns, like it still holds up. Like a lot of like you have to start like removing some of the fine details what they're talking about, but you design to an interface, meaning that the interface is always the same. So if you change the bit that talks, nothing really minds.
Yeah.
Use things like the observer pattern lets you have different numbers of observers without having too much coupling between the two systems. PubSub is a logical extension of that. And it's like when you start adding these kind of more interchangeable systems to your bigger design, you get to be able to do these things where, as you say, literally like change the sides of the car while it's driving,
Yeah.
literally change the fuel at times, which is when it gets really strange. I know it's a bit of a tortured analogy at this point, but it almost is true. And like you get to these kind of odd systems points sometimes where you're almost like, right, running a system in one language, system in another language, and then you basically waiting to the point where you could turn the first one off. And it's like amazing to see these things happen these days, as they would have previously just never been thought of. You just expect some downtime.
Yeah, that's just what I find fascinating about architectural design. Just obviously you can't just switch things off one day. You decide, right, we're just going to get rid of that piece of architecture. Chances are there's a high chance you need it, but you don't want it in this big block, which is obviously why we're here with microservices. But it's just difficult to comprehend. That's why we're here. Go
Oh,
on.
I know, yeah. It is very difficult. Like that's the kind of thing though. It's like this is where it kind of like there's a lot of traps though as on the lines. Microservices are brilliant when you get there, but getting there is hard.
Okay.
Like, you don't like people think you can build these webs overnight, like of all the distributed services, but that's not really true. Like fundamentally, like monoliths existed for a reason, which is that they're relatively easy and quick to build. And like I've seen this happen sometimes with companies, which is that, they start out microservices and end up having to go back to a monolith just to get value faster.
Oh, really?
Yeah, it's something I've seen happen a couple of times now. It's, you start with these distributed bits which are supposed to add value on their own, but fundamentally you're not at a point of scale or of value or kind of product market fit where it's actually going to add any value. And without the whole service, fundamentally, they tend not to actually even have a product. So unless you can, let's say, sell your goods already, there is no value to having a microservice that handles payment as a finished product. It just doesn't do anything for you.
Okay. Product market fit. That's something that I'm going to get chatting on here. I'm going to get someone, if there's anyone in the audience that wants to talk about product market fit and aligning technology to that, or a system to that, product to that, obviously, come and talk to us. Come and talk to us. That'd be awesome. If you've
I'd
got
love to hear that as well.
good, if you've got any advice, Ben, for engineers stepping into the world now, what would you say to them?
So, like, it comes down to kind of a few different points of levels of experience. Like, if you're fresh out of like whatever you were doing previously and you're new to the engineering world, whether you've just done a degree in it, a boot camp, or anything else, like the big thing to understand is that it's okay to know nothing, which is something, like it took me a while to realize it's fine not to know, right? And in some respects, like it's better to be very clear on what you do and don't know, right? Everyone has been in that situation.
Yeah,
Anyone who's been a software engineer for more than a few years will have been in a situation where they've been asked if they know something, and the answer is they probably know it, but they're not really that sure. And they'll say yes, and then they'll end up having to build or deliver something they really don't have a full understanding of. And that's risky from everyone's perspective. Yeah, occasionally you learn and excel, but everyone who's been around for a while will tell you a story of when everything went wrong. And it's
yeah,
kind of like like particularly now, we've got to the point where there are so many systems so far removed from just like bits moving on metal that like it's completely unreasonable for everyone to understand everything. I mean, totally. Like, I'm not really a front end web engineer, and like I was being talked through one of my team members' React system recently, and I was like, I am already lost here. I thought I didn't think we needed compilers for the front end in JS. And the answer is, well, now you might. And it's something like, this is kind of evolved a lot since I last did this in anger. And like, maybe that's showing my age a bit, but like, this is the thing right now is that everyone has become more specialized. If you're new,
Yeah.
don't worry, you'll get there soon enough. Like, but don't try and do everything. Just and be very kind of like very open about what you don't know, because people are there to teach you, right? You can learn pretty quick, but you need to know. Everyone needs to know where you're coming from. That's kind of first bit of advice, I suppose. And as you kind of move up the tree, it kind of becomes a matter of like, there are various core things you'll learn, like the mathematics of how things work, understanding how to actually build things that genuinely scale, are secure, uh, are trustworthy, are reliable. And those sort of core elements of engineering are just kind of good experience. But after a certain point, you're always going to be measured on what is your best single skill. True generalists either have tons of experience or don't exist, and it's not worth necessarily being a true generalist,
Yeah.
at least as your kind of primary offering. There was a line I remember from back in my consultancy days, which was you can have like to be a T-shaped person, which is a broad area of expertise, of general expertise and knowledge, but then a one deep area of true expertise.
Yeah.
Where you go all the way down the stack in whatever technology of choice would be.
Yeah. Well, two things in there. We did a podcast with Yan Chi, AWS serverless guy, some months back, and he gave some really good advice on go really deep in one area. If you're coming into the industry, go really deep and specialize in one area or one part of the system at your company. Get really good at something and obsess over that. And another point, I think, we find this in life again. For people to learn, I think just generally, whether it's software engineering or in life, I always say leave your ego at the door. That's one that I particularly like. I had to do that when I joined the gym. I had to do that. I know it's off topic a little bit, but
I completely understand. Yeah.
You have to just think, okay, what I think about myself to be able to get to where I want to be, you kind of need to leave that at the door. Be prepared to ask questions, be prepared to do things in front of people that you usually wouldn't do to get to where you are. So I like that advice. Be prepared to ask questions. It's okay not to have all the answers.
Yes, for me, this was kind of a big thing. Like, when I took on this role, like, although I've worked in the kind of the Devrel type space before, like, there are various things for the more Devrel specific community things I am not totally aware with. And like, particularly, I said front end web, not really my thing. And like, I have some people in my team, particularly one of my engineers, she is one of the best front end web people I've ever come across.
Yeah.
Right. But like, I'm just going, don't know, please help, don't know, please help. And like, it took me a lot of like actual years of experience to get okay with just asking for help.
Yeah.
On things, which are relatively easy in some areas. But then again, like on the flip side of that, right, is my area of expertise tends to be, dealing with like interfaces between languages. So, like a query came up of how do I talk to a .NET 2.0 system from a .NET 4.6 system? And there are some hilariously interesting tricks when you get down to it. Like if both systems treat each other like a C library, they'll never complain because they'll just talk over a well understood ABI. And that actually is something most people don't think is possible. But I learned it from a weird place of trying to build a Unity app running on a Google Glass of all things. So going from Java into mono C sharp means you end up with this really bizarro interface where you basically pretend both sides are C and hope. And it works perfectly because you have this well understood like thing, but it's not something most people would ever know because most people haven't had to do that specific thing once. And it's the sort of thing where it's very easy to answer the question if you know the answer.
Good.
And that's the thing, like asking questions is the only easy way to learn because like learning is painful, and I'd much prefer someone to tell me the results of their pain than me suffer.
I completely agree. I completely agree. I'm conscious, obviously, we've taken up quite a lot of time and you've got things to attend to, I'm sure, with Ably. So, do you want to wrap up for us a little bit about maybe some of the people that you're looking for, or why would you want to join Ably at the moment if you're an engineer listening to this?
Okay, so we have a few roles open. It's best probably to look at our website for that because they do change a bit. So one thing we're kind of in a big thing right now is we're trying to grow what we call our expert network, which is people who want to write articles around content in our space. Whether it's Ably specific or not, we really want to have this kind of just a web of content which is valuable to the world. Part of this, and like also our open source development, we open source all our libraries and things built with our libraries, so that we're looking to try and recruit people to help build those, and also to build demos and cool stuff. Literally, if you want to build something cool with Ably, sign up to the expert network, and we might even pay you to do it. And this is everything from literally a series of arcade games we're doing in multiplayer. One of my awesome team members, her name is Shrishtika, she recently finished a whole article piece on multiplayer Space Invaders, where an unlimited number of people can play as the invaders.
Okay, nice.
And like literally, we will like if it's an interesting thing you want to build with Ably, come to us and we might provide some money to do it.
Good.
But on the flip side of that, we're hiring, I believe, a lead SRE, a VP of engineering, and a few other kind of really senior roles, and some more general ones. Like for us, as long as you like what you really care about what you do and want to be part of something which is, we're generally trying to like go big, hit this hard, and actually like achieve something quite different. We're trying to be as open and inclusive as possible, and if there's a role that you think fits, just apply.
Good. I think you've done a marvelous job of Devrelling today. Uh, I love some of this content. You've gone really, really in depth. Thank you for obviously taking the time to have a conversation with us. Guys, share this with your network. Check out what Ably are doing. Check out what Ben's doing. Follow us on Twitter, Enginears.io. Follow us on LinkedIn. Give us a share. If you're at a company and you're really proud of some of the stuff that you're doing, some of your peers are doing, just drop us a note. We can get in touch. We can help you build a podcast structure. We can come and talk to you. We do everything on the podcasting side. We want to hear from you. I can't say this any more times. I will write a blog or something so it's more visible, but we just want to share and educate people on what the community are doing. Companies in London, Barcelona, Amsterdam, we've got Berlin, New York, we've even got people in Australia who are keen to talk to us. So if we can make the world a smaller place and make all of this content accessible, we're trying to play to what Ben's saying in terms of learning. So that's what we're really passionate about. So just give us a share. It will go a long way. It will go a long way. So thank you, guys. And Ben, thank you so much.
You're very welcome. Thank you for having me on.
My absolute pleasure.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website which is Enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.